Great. Good morning, everybody. My name is Jordan. I think all three of you here know me, but in case anyone else is watching this recording later, we're going to spend our time going through some problems here. The first problem we'll work on is valid spacing, which Adam requested. It comes from Code Wars, but it's on the beginner tab under strings 2 on CodeTrack right here. So on CodeTrack, you have all of your, not all, but many problems organized by difficulty, and then under difficulty organized by topic. So this is going to be a problem dealing with strings. Here is the link to this problem. I'll put that in the chat. If I can find the chat, there we go. And we'll go over this, probably won't take too long. We'll see how it goes. Here is the description. Open this up just a little bit. All right, your task is to write a function called valid spacing, or valid spacing, just depending on what language you're working in, which checks if a string has a valid spacing. The function should return either true or false, or the corresponding value in each language. For this kata, the definition of valid spacing is one space between words and no leading or trailing spaces. Words can be any consecutive sequence of non-space characters. Below are some examples of what the function should return. So here we have what is a valid string, 2 words with 1 space in between. We get true. Here we have a leading space, which no matter what comes after should be false. Remember, it says no leading or trailing spaces. Here we have, looks like 1 space here, but we have trailing space, so false. Here we have 2 spaces. Got to kind of be careful there and drag your mouse in case you don't catch that. That is false. Here we have 1 word, no spaces, true. And here it's valid, 1 word, no spaces, 1 word, 1 space, that's false because again, it has a leading, a trailing space. Here we have, I think that's just 1 space. Yeah, 1 space, but no words, and no words, no spaces. So they do a really nice job of laying out all the cases for us. Let's go ahead and get started with working through this problem. Hey, Christian, how you doing? We're working through this problem right here at Adam's request. So let's open up our tests a little bit and delete a bunch of these. All right, so before we even get to this kind of case here, we want to start with our base case. Our base case is the simplest valid input. And in this problem, our simplest valid input is going to be an empty string. So with that, we want to write, what is the code we can write to pass that? And that can simply be return true. All that needs to happen to pass this one test is to return true. We can run our tests and we're going to see that that passes. Very simple. Too simple, you probably say, but I promise you, not too simple. Will serve you better as problems get more and more complicated. Here we should put a message that says handles an empty string. Great. Here we want to handle the next simplest case, which is handles a string of 1 word. Okay, and in here I'm just going to put I don't know, Ford. Why Ford? Don't even know. And that would be true, of course. So we can just run that again. Good. However, when we're dealing with 1 word, oops, I didn't mean to make that bigger, but rather the tests, we can have some false cases in here as well. So 1 word can have both a leading space or a trailing space. So this would be false, right? Now we have a leading space here. Let's go ahead and run it. And now we see we are failing because we're always returning true. Let's write some kind of conditional for that. If s at 0 is equal to a space, return false. That should be all we need to return false for that particular case. We check if this is an empty space, and if it is, we're going to return false. Try our test again, and we're good there. Okay, now we want to try for a trailing space. So I'm going to delete this space here and add a space here. And of course, if I run my test, we see that it fails. So let's go ahead and add 1 more condition here. If s at s dot length minus 1, in other words, the last index, If that is equal to an empty space, then we're also going to return false. Let's go ahead and run that. Great. We see we're passing both of those. These are all the configurations of one word.
Okay.
Of course, we can add more space here or more space here, but it would be the same.
Voy a poner radio entonces.
And let's move on to the next one. Handles a string of more than one word. Okay, so here I'm going to do forward foundation. And that would be true. So let me just comment out both of these for right now. Let's run that. Yeah, so far so good. Nothing has to change there for that to work. Here I want to do forward foundation. Now we want to test at least 3 cases here. I'm going to start with this case where we have more than one space in the middle, and that needs to be false. I run this and I see, yep, I've got a problem here in that this case returns true currently, but it should return false. So what logic can I use to tell the computer return false in this case? There's a couple things I can think of. One would be use a regular expression to look for any sequence of spaces. So anytime I would see more than one space together, anywhere in the string would return false. That would be one approach. Another approach I can think of is split on single spaces and check that there are no empty strings. Let me demonstrate what I mean by that really quick. Strings. If I take a string like A space space B, so there's 2 spaces here, and I split this on an empty space, the result is going to be an array with an A and then an empty string and then a B. Yeah, because right here in the middle of these will result in empty string. That's when we split on a single empty space. So then I can take this array and I could do something like this array dot every word. Sorry, again, can't spell. There we go. Word is not equal to an empty string. And this would return true if this doesn't exist. It would return true for this, but it would turn false for this. So that is another way we could do this. Another way we could do this is we could loop through the string and check for any spaces next to each other. Hopefully this survey of ways to solve this is somewhat useful. So here I can do for let I equals 0, I is less than s dot length I plus plus. And here I want to say if s at I is equal to a space and s at I plus 1 is equal to a space, return false. Let's go with that since I just wrote the code. But that's at least 3 different ways to get this done. And I'm sure there's many more. That's just the 3 that kind of occurred to me this morning. All right, let's try that there and see. Yep, now we see that that does fail. So our pointer I goes along here checking F and O and R and D and a space. Okay, fine. But then space and a space. And now we get false. Cool. So I'll leave these notes here for a minute until we start to clean up a bit. All right, our next case, we want to bring in forward foundation with a leading space, and we'll just have it have a leading space or a trailing space. Again, no problem here, right? Because this is already handling this. So we can do a trailing space here, but it is really kind of redundant at this point. We'll test that. Great. And let's just do a couple more tests here. We'll make sure we capitalize this and capitalize this, and otherwise that should be true. No reason that shouldn't work. And let's put more than one space here. We'll do I love thee. So all single spaces here. Until here, this string would be valid. But once it gets here, we're going to have a problem. I think I left that as true. That's my bad. It needs to be false. Great. And we'll do one more. And let's do multiple spaces at different places. So fail, 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 and it should fail regardless. Cool. Any questions so far? Okay. This is a runtime of n as it's currently done. Here we have a runtime of 1, checking the front and the back. So it doesn't matter how long our string gets. These are still just going to take 2 steps. Then here we iterate over the whole string. Now, because we've already checked this space here, we should be able to actually start this at 1 and just squeeze a tiny bit of efficiency out of that. So I will run that like that and make sure that everything still passes. Looks good. And then return true, which is just runtime of 1. So this is what creates a runtime of n right here. And given that I've written these notes down, I'm just going to delete these. So those are, like we said, 1, 2, 3 different ways you might approach this. Let's go ahead and just leave that one. And I think we're ready to submit this problem. Can anyone think of any cases that I'm missing? Can review here. We have valid string, leading space, trailing space, more than one space in the middle, single word with no spaces, longer word with no spaces, longer word with trailing space. Oh, a single space. I think we're handling that, but we don't have that in our test. So let's make sure we get that. Let's make sure we get that down. So I will do, it handles a string of only spaces. So here we want to say that is false. I'm just going to be very cavalier and make another test right away, which is just more than one space, and that will also be false. Great. Always good to go back and check the description. Again, I don't think that will fail on that, but it's good to put it in there. Okay. And then an empty space, which we definitely have. There's no punctuations or digits, only letters. I think we're good. Great. I'm going to go ahead and click attempt. And we see we pass everything on the first time, just as it should be. We're going to call that a success. Let me put my code up here one more time. Any questions here?